Welcome to a new test and teardown video. Wow, we are playing with oscilloscopes, aren't we? This one is a Philips PM3244. It's a 50 megahertz analog oscilloscope with 4 channels, 2 time base, delay. It can do a million cool things with the time bases and with the way that it's merging channels, positive here, so that it will merge A and B together and create the result of A and B. But you can see you can have A, B, or A plus B, but you can also have A and B as well, and you can continue to do that with all these others. It's just so nice. We've got chop and alternating. It's full blown 4 channels with all the stuff here. So I can't wait to test this and play around with this. Oh yeah, by the way, we even got the front cover. And that is what this little hole is for, in case you got one of these scopes and don't have the front cover. There's a little thing missing in this front cover, and that is this plate that goes in here and locks to these, and this is where you will normally put all your scope probes, and then clickety click here, and then you put this on and turn it here, and then it's all locked and you have everything where you need it. So I'm trying to find the power supply, because there is a reefer capacitor right there inside the power supply, and that is just notorious to blow up and cause a million other problems. So this is what I really want to do before we can even start playing with this unit. So to get access to the power supply, yeah, you pull it out from the back. So this is how it's done. We take out this one by just those 3 screws. I really like this design where you take your mains cable and wrap it around here and stick it in, and then everything is nicely and contained like that. Okay, I would have liked it a little bit more if we had a modern IEC connector, but it's not that easy to fit here, because you got the on-off switch here and the brightness potentiometer also in this little room down here, and then a long stick to the front. Classic way to do that, by the way. Yes, I want to go in here and look at the reefer, and then we can start to look and play with this scope. So before you start pulling out things like that, always make a note about what goes where. But in this case, we got different connectors for everything, so it can't just be pulled out, except for this. So we need to note these colors. But what do I see here? I see all sorts of leaky, nasty stuff on the power supply. And then I get sad and worried about how many capacitors we got that's leaked, because so far it's looking a little bit bad. Oh, no. This is not how it's supposed to look. And this kind of damage we see here, that is, if I'm not mistaken, a previous exploded reefer. Somebody just plugged in a new reefer instead of taking a better brand. And how about cleaning up all this? Why don't you do that? As you can see here, this is how it looks like when one of these just explode all over the place. And yeah, capacitors here, some of them leaked, and nobody cleaned up anything. Just put in 2 new ones and then run as fast as you can. I mean, this is not how you do it. And you kind of, what's that? I need to dig a little bit further here. So I go Google a little bit on the internet, and those are actually pictures from the internet. Look at that reefer. That's exactly the same power supply. It guy called John. He had exactly the same problems, and it is exactly the same explosion. Here is something very, very funny. Look at that capacitor and look at the two holes right there on that capacitor, because the reefer exploded in that side. And then we go and look at this one. You are not going to believe it. This is almost scary. Let me go down here and crank on the light. It is exactly the same two holes, and everything here is exactly the same. So I thought that maybe this was that scope, but that is not the case, because we got a few other differences. For example, this resistor here, and tiny little details that is indeed proving it is a different power supply. But it's funny that we see exactly the same problem or explosion. I'm going to remove every component that is super duper puked and have all this cleaned up. Oh, look at all that. And probably also going to change the rectifier, because that is also super duper puked by some gross stuff. Sometimes when you want to clean up the remains after a leaked capacitors, I believe those were the ones to blame for all the destruction in this area. I've removed this connector to get access to cleaning. As you can see here, it is going to be a problem if you don't clean this. It's going to corrode and remove the tracks in the near future. So this is what I'm gonna do, clean it proper. So I feel I'm done with the power supply for now. All nice and new capacitors. This one was cracked as well. I inspected all these carefully and actually measured a few of them, and they're super duper tip top. So I believe it was debris and all sorts of bad flames from this area that made everything dark and nasty, and of course the remains of the acid leak from these. So I cleaned everything and added a thin layer of varnish to all the tracks and stuff. The transistors, they are in sockets, and they also needed a deep clean and varnish from below. All the tracks and all that stuff, yes, a thin layer of varnish, and also glue the capacitors together, because otherwise they're gonna go flippity when you drop this on the floor. So this one needs to dry a little bit more, then it's gonna be fine to assemble this one again. Also added a little bit here. It doesn't really look super beautiful, I'm sorry, but I'm not a painter. Have you seen these coils before? It's quite funny, because I believe that exactly this plastic holder or frame or whatever you want to call this is normally used by Philips as well as their reed relay holder here. So there's the reed is in here, and then thin windings as well. So I bet they got a winding machine that handles exactly this form, and then it's here, it's just used for power inductors for filters for all the DC voltages. Oh yeah, by the way, this is mains entry, and the components here, and that optocoupler and the components here, that is of course the trigger output, so you can select mains trig. So I'm doing a little bit of deep inspection before I power this thing up. It's quite interesting to see all the cool things. So here is a vertical amplifier, right? The wires here goes straight to the CRT, I bet. Yes, they do. And the input of the amplifier comes from these two cables, and I'm gonna show you where they go. There is a very special delay line in this unit. Of course, this one is from 1979. So of course you would expect somebody did a little bit of service now and then. You can also see a lot of green goop. I don't know how that is easy to show here, but I see it all over the place. Nice shielded cables, and this is all the analog stuff here. Oh man, it's completely full of transistors and ICs, SMD ICs from 1979. Oh, they even have a nice, oh yes, look at that, nice little date code, 1979. So they're called what? OQ002. And here I will show you a little snip from the schematic. So you can see there will be some transistors and some diodes. And that is the same IC they're using all over the place. The IC you see, that is what you get all the different places. So it's very versatile and can do everything they want. Nice filter for all the power supply and low speed in out here. Thermal matched, low drift kind of stuff. And again, look at all that green slime. It's all over the tracks. It's, oh man, there's a lot of cleanup to do here. It's in there as well. Oh, this is bad. And is this stuff easy to, yes it is easy to remove. So let's take the clean end here and just see what happens if I do a little bit like that. See, old green slime. This can't be good. But I was actually told this scope was supposed to work. So let's just do one little inspection. And then let's power it up and see if it works. Oh yes, I promised to show you guys the delay line. Oops, that is the high voltage oscillator. Yes, here it is. Here is the delay line. It is inside this big box that goes all the way around here. So we got a matched 2-wire in and 2-wire out, and they're really cool inside here. It's many years ago since I scrapped one and took one of these apart. I'm so sorry I don't have the pictures, but it is really funny to take this one apart. But I will not open it and I will not show you what is inside. I'm so sorry. But that is definitely the delay line, so we should expect this to be able to see the leading edge of a pulsed signal. So here's the bottom of the unit with all the input attenuators and first stage amplifiers, and then it goes all the way down to all the amplifiers you already saw. This is a more traditional board here that's doing all the interconnect of everything else. Yeah, I need to go and have a little look for loose parts. I still see green slime all over the place, so yeah. Anyway, I kind of like all those shielded cable for stuff that goes fast. But I feel like we should try and power this up and see what happens. I thought I was more or less done with my inspection round here, but look at all this corrosion here on the aluminium. So this reveals the unit was stored a place with high humidity. So this is on-off switch down here. What I want to do is, as you can see, I got my ground on chassis, and then let's just turn on mains entry, and that is fine. Let's turn off that light so it's gonna be more funny. 13 watts, and yes, we have light here, and of course it works, so that is good. Oi, oi, oi. Holy shit, this is bright. This is way too bright. Oh my goodness. I have to turn this off. There's definitely something with the high voltage. Holy shitter, this is not supposed to be this bright. I don't know how that is easy to show on a camera, because they will just change shutter and all that, but I can tell you that was looking into the sun. I'm still fighting with this annoying blanking issue. So what I've done is I traced the white and orange wire. So this is the high voltage supply, and this the input is 45 volt and the output is 1600 as far as I remember, right? So here's the 45, and that is spot on. So let's try and crank it on. And see, we got negative 1600, exactly as we're supposed to. And look at that brightness, absolutely crazy. But it also has something to do with, as you can see here, this is the blanking that is not working. So it goes here and it waits, and this is the trace, and you also see the trace here. You see there's blanking between the traces and all that. It's just crazy how powerful it is. So I bet there's something crazy going on with the blanking. So I think I finally figured this out. Let's do a little bit of a demonstration here about what is going on. It's still upside down, obviously, so don't be all confused and all that kind of stuff. So here is the position. See, now the start of all the traces is nice and dim. So if I put it like this, so you can see what's going on. So this is of course all the different blanking pulses that's coming in here. So there's a potentiometer here, a trimmer, that is doing the ratio of the trace return blanking. And if I play a little bit with that trimmer, you can see here, we can restore the problem. Well, now I can't restore it because I kind of cleaned the trimmer. The idea is, here is where you want to have it, and this way you can control the normal brightness like this, all the way to 0. I think I completely nailed it by simply cleaning the trimmer. Ha! Now we can start playing with this thing. Isn't that just wonderful? I also went through all the time base stuff here, all the sockets here. They were completely green by this green slimy goop. So all this board here is clean, and all this blanking board here is cleaned. So that means I can flip it around and let's play. I think I got this figured out. So right now I got 2 channels input, and like you can see here, I am on channel A and B, and here's my trigger is selected for B, and then all I have to do is find the trigger point like that. Oh, it's very bright, the light here in the background, and of course you should crank down the brightness here, adjust the focus. Fantastic. I'm having a little bit of blinkety trigger stuff, but as you can see here, my screen is nice and blank and all that, and this is of course in 4-channel mode. I went through all the different tricks here, and there's a little funny thing about B. The DC offset for the trick is a little bit off. See, here's A. Let's go to A. Let's style in A. Okay, here we go. This is in the middle of A, right? So if I go to B, click on B, and then I think this is a little bit funny. I need to dial it all the way down there. Okay, let's go to C, click on C, and then I need to go all the way back, like that, in the middle of C. Okay, let's go to D. See, and then it's all the way a little bit down here. I don't know, why is it like that? There's probably a trimmer for that. So I'll go and play a little bit more with this before I come back and play any kind of clever here. Meanwhile, I can show you a little other thing that I've been playing around with. The missing plastic piece here around the screen didn't really bother me in the beginning because I didn't know if I was going to make this scope work or not. But now we have a very promising future for this scope. It's definitely working. So what I did is I went out and grabbed another front from another random Philips scope, and it sort of fits. It's the same kind of screen, but there's some kind of mechanical stuff that's definitely different from scope to scope. And if I look at another Philips scope, they still got the same kind of screws here. So the idea is you can screw on stuff, but on this scope it's completely different. It clicks in here like that, and then clickety click down there, right? So this is not compatible in any way. But what I could do from this, I could steal the design and the idea with the height here and the thickness here. How deep is this? How big is that? All those kind of things I could steal. And then I took some measurements on an old used paper, because I'm really trying to save the trees, as you can see here. So this is the kind of paper quality that I use here. I use all my papers 5 times on all sites and stuff. So, so here's my notes for all the different measurements of this screen plastic. And then only a few more minutes in a little 3D design software, as you can see here. I think I figured out how to make this screen plastic, and it's only going to take about 2 hours. Then this will be done from the 3D printer, and then we'll see if it fits. Done with the 3D print. It's going to be interesting to see if this fits. And that turned out to be quite nice. After support is removed and all that, you're gonna use screws like this, so it's gonna look quite alright. So that turned out to be really, really nice. I'm quite happy about the result of a homemade CRT shadow plastic thingy, and it fits perfectly fine. What I've done is those files for this STL file is on Thingiverse. So if you got a similar or actually many of the different types of Philips scopes, they use the same holes and the same everything around here, where you could use this file. So just 3D print this yourself, and then you're done. I will put the link in the description so you can go and get the file for free. I've been sitting and playing a few hours with all the different time bases, and trick this and trick that, and delay time base and the delay settings, and it's a fantastic, funny, cool scope. Definitely. Well, when I was sitting here and playing, suddenly I heard some arc, spark, pifty, poofty, and then, oops, no more picture, and power consumption was just 5 times as much as normal. Oh no. Fuse is blown up. So that is a good sign. That means I have a high risk of saved. What else is the problem? And this one is known to be a problem too. So what I will do, as you can see here, mains goes in, there's the switch with this long stick that goes to the switch, the fuse. But the fuse is, I think, before this filter, right? So that means if there is a short inside this filter, I'll try and take this away and then see if I can put in a new fuse and is it okay. Sometimes I kind of love it when my intuition is right, and this is very, very good luck because this is going to be a very easy repair. Remember, the original fuse blew and I put in a new one. I just put in a 1 amp fuse and I unplugged the scope and then I turned off the mains on-off switch that's in here. Then I only gave it 14 volts of mains, that's it. And then I turned on the switch and then poof, fuse went. So I totally proved that the problem is in here. Here's my first try. I'll try and bypass the mains filter. And here's the dodgy filter. I think is the problem. It says a lot about the components that it consists. Yeah, but this one is shorter and just eats the fuses. At least that is my theory. What else can it be? And here we are without the mains filter. This looks perfectly fine. I think we are back to business. Now we can play. But I really would like to solve this mains filter issue. I can't have wires hanging out of the back. That's not good. Alright, I think I covered most of all the stuff that I wanted in this video, really. I had a lot of fun so far, and now I'll go and play a little bit more with it. Oh, as you can see, there's a little bit of drift on that one. That's funny. So thank you very much for watching so far. Hope to see you soon again. Bye bye.